Greetings, Earthlings. Well, it's time to take a look at these switching MOSFETs and see if I can get this thing back working again. I have received the replacement parts, 3N163s. One thing I noticed with these is the pinout is different than what's in there. So what's in there is an HDI G1030, and indeed, oh, see, I've taken the this little clip off. Again, I'm not really sure what that clip is for, if it's a thermal thing or if it's or what. If we just check, because you see it's got this like glue or plastic between the two clips, and so you can see that that is, oh yeah, okay, there's my fingers. It's electrically insulated. I kind of believe it's thermally insulated as well. That's hard plastic or glue. It almost looks like, you know, Elmer's glue or something in there. But I'm not going to worry about that. Right, the pinout is slightly different. Here we go. And how did I figure out what the pinout was on those? Because I don't have the data sheet for that one. I don't think. Maybe I do somewhere. But anyway, just checking with the ohm meter. So the replacements go drain, gate, case, source, and the one that's in there is drain, gate, source, case. That doesn't matter in the case of one of the MOSFETs because this case and the source are connected together. That's the one with the X, which is the bad one, but I am going to replace both of them. Yeah, I don't know, you can see that, but those are connected together. But on this one, the lower one here, that's going to make a difference. That's what they look like, the new ones, and they have these little, they come with these little shorting rings on them. You see that? I don't know if you can see that or not. So I've taken one off. We'll get to that in a second. But turning it over, there's this strange circle here, and then what looks like a Teflon donut under there. So I'm not sure exactly what's up with that. See, the gate goes into these little wells, which also seem to have Teflon circles around them. So let me take that off and see what's going on there. See if I can. Oh yeah. So yeah, as you can maybe see, there's a grounded disc. And I say grounded because this wire here, which was under the, hold down that, it goes over to here, which I believe is ground. It has these, well, I'm seeing what looks like thermal compound, which again I find strange. And then it has these little things which may come out. Yeah, look, they pop right out, and indeed it seems to be filled with thermal grease. Which again I find odd. And then so here's the underside of where the gate and these twisted pair leads connect, and the other leads are here somewhere. So that tells me maybe they are trying to keep them at the same temperature, and so maybe that's the purpose of this, part of the purpose of this, is to try to keep them at the same temperature. I don't know. It's weird. I've never seen anything quite like that. Okay. Well, we'll get to it. What I want to do right now is if I can bring this in. So I've taken one of them, which I'll probably destroy. Taking one of my new MOSFETs. And I've hooked it up, and there's an ohm meter over there. Okay, the ohm meter is connected between the drain and the source. The gate, the source and a case I've connected together. Case also being the substrate, and so I've got between the gate and the substrate, we'll say, a variable voltage, which is coming from the Fluke 343A. So this is with 0 volts at the gate, and that's reading roughly a megohm. I don't know. It's basically open circuit. I don't know if I went negative if that would read higher, but what I want to see is where it turns on, because I'd really like to, I guess, try to sort of match the two I put in terms of their turn-on voltage. And I could use the curve tracer, the B&K 501A, except these are enhancement mode MOSFETs, and it's set up for depletion mode MOSFETs. So you have to kludge it for enhancement mode anyway. So this is my kludge. We'll just measure the resistance. So this was 0 volts, set it to 1 volt, 2 volts, okay, it moved, 3 volts, 4 volts, okay, that's pretty much fully on, I would say. That's reading 1,000 ohms. Well, if I go to 5 volts, yeah, it doesn't really change much. Now, it says here that the maximum RDS on is 250 ohms, but, well, somewhere between 2 and 5 volts. So I should be able to go, what is my gate breakdown voltage plus minus 125 volts? Okay, so I should be able to go to 6 volts, 7 volts. Yeah, and it doesn't really change much. I guess I'll play around with these, and what I should do, actually, now that I think about it, is I should take this one out. This is the good one. So take that out and measure it like this, and then try to find a pair that basically kind of match that thing's characteristics as close as I can. Okay, this here, if you can see it, this is the MOSFET removed from the board, the good one, and 0 volts in, there's 1, there's 2, oh wow, so it's basically fully on around 2 volts. This is 3 volts. And you have a lower on resistance than the replacements. Is this going to mess this up? I'm not sure. I do see the it's driven. Let's see, it comes from here. Okay, that drives the gate of this one. This one is driven from down here. So this circuit up here, this does have a drive waveform adjust which is not well described in the manual, which may be able to overcome that difference. I'm not sure. But yeah, these new ones are spec'd to turn on. Well, it says -2 to -5, so it's possible that I'll find some that are on it too. Right, and so here we are. What I did is I went through, I had bought 10 of those replacement MOSFETs, and I went through all of them and measured their resistance with the varying voltages, and found the two that seemed like the closest match to me, and that was numbers 6 and 7. I numbered them all on the, wrote the number on the top. It's still quite a bit different from the original, in that the original turns on at a lower voltage, but by 6 volts, you'll never know the difference. I don't know the exact switching voltage it uses, but hopefully those will work, because that's what I've got. So there they are, 6 and 7. You're not going to be able to see this, but 7 has its legs swapped, the case and the source legs. This one just went straight in because those two pins are connected together right there on the back side of the board. Now the question becomes what to do with this, the goop. I do have some thermal joint compound. I can't understand what's going on with this, because, you know, generally this is used to fill in, you know, those tiny gaps when you clamp a part to a heat sink. That just fills in the tiny gaps. There aren't great gobs of it like there are in here, you know. But I think the thing to do, since those plugs come out, is to take this old grease out, because it's kind of hard and crusty and not really filling the space, and fill it up, press it on, it'll ooze out through the holes, and then put it all back together. I don't think that's probably how they did it when they built it. Probably they used those holes to inject it, but I don't have anything that I can use to inject it. So yeah, like I said, that seems weird to me. If you can explain it, write a comment. If you worked at Keithley, even better, if you're the guy who designed that. All right, what I decided to do before gooping it all up and everything is put it back together without that cover on, just to see if it's semi-functional now, huh? So I've powered on. I'm in the DC volts range, feeding it here from the, well, first of all, let's put the shorting bar in. Give it 0 volts in, guaranteed. And already you can see this is a good sign. That's pretty close to 0, okay? Needs calibration, but it's not that far off. Okay. So, that's a good sign. We'll feed it from the Fluke 343A. I'm on the 10 volt range. I'm in the 10 volt range here. Let's give it 1 volt. That's pretty close. And, you know, on 0 it was -4, and 1 volt goes to 0.9995. So there's an offset of like -4 millivolts or so, which can be, I'm sure, calibrated out. 2 volts, right up to 10 volts. Don't like that. 9, 8. So, oh, okay. So now it's showing over by a bit, so there's a linearity issue there, but it's good to 8. 9, not so good. And 10, no different than 9. Okay, so there's some issue there. But 1.1, okay. Go to 100 volt scale. This is 10. Oh, okay, well, go to 100 volt scale here. 10. Settles in eventually. 10, 20, 30, 40, 50, 60, 70, 80, 90, same deal. Okay. So some issue there with the DC. Let's switch to resistance. Got it plugged in here to a Genrad 1433P decade resistor box. This is 0. Let's see, this goes up to 1 megohm in 10 ohm steps. So let's go, well, all right, that's K. So 1K. Okay, reading a little under. And 2, 3. This is probably the same problem as with the DC calibration is just off. 8, 9, 10. Okay, that's not bad. But let's take it up to, this is 70, 80. Let's see if it does the same thing here as it did on the voltage scale. Yeah. Okay, I'm at 100K right now. 90K, 80K. So it's good up to 8, and then it goes, okay. AC volts. For that, I have an a Fluke 5200A. Let's see what it does. And I've got that set to 1 volt out. 1 volt. Well, it doesn't matter, does it? It's okay, that's not working. So, I already made one repair on the AC converter, but apparently there's another problem there. Go to 10 volts. Yeah, it's just nothing. How do I know that's working? How do I know my Fluke 5200A is working? Well, I can plug the output of this into another meter I have over here, which is a Fluke 8500A set on AC volts, and operate. You know, it helps to click it into operate. Well, it was operate. Okay. And that's reading about 10 volts now. Okay, so it is on operate. Let's make sure. Over here. I'm on 10 volts. Yeah, still nothing. Okay. So, I could try current. Well, I could try current. DC current. I'll turn this thing on. Okay, at about 100 milliamps, DC, 100, let's see, where? Oh, that's microamps. Ooh, nice. 100 milliamp range. Okay, and I'll switch that on. Should be somewhere, well, again, 81, where probably, if I bring it down to about 80 milliamps, Okay, 77.5, 77.3. Yeah. So again, that's showing the same problem as the DC, where it's sort of topping off at 8100. That's interesting. So still a couple of problems, but definitely major progress. So I guess I will put it back together. Go ahead and put the goop in there and put that board back in, and then I guess run it through the DC calibration is the next step, just to see if I can get it within calibration, or if that topping out thing is another problem I have to deal with, or just can be resolved by recalibrating it, and then we'll proceed from there.